Welcome to a second lesson in proportionality and changing quantities. In the previous lesson, we had talked about making a mixture of Diet Coke and lemon juice that would preserve the taste. Let's look at another example now. Suppose you paid an initial cost of $75 to join a gym. Each month you are a member costs you an additional $30. So what we're going to do is we can create a table based on the number of months you've been a member. And so the question is the total cost that you've paid to the gym proportional to the number of months you've been a member? Justify your answer using at least two ways of thinking proportionally. So again, to recall, there are three ways to think proportionally. This question is asking us to look at it two different ways. So there is a scaling perspective, the constant multiple perspective, and the constant ratio perspective. Let's first look at the constant ratio perspective. So what we're going to do is we're going to look at the ratio of the total cost of dollars to the number of months since you joined. Because we're looking at the total cost of dollars as output and the number of months you joined as input. So the ratio of output to input. Take 105 over 1, that's 105. If you take the next set of input and output, you take 135 divided by 2, that's 67.5. If you take 195 over 4, that's 48.75. And if you take 375 divided by 10, that's 37.5. So clearly, we do not have a constant ratio. The quantities themselves are not proportional. So we have verified that this relationship is not proportional using one of three perspectives of proportionality. We think we'll come up with the same conclusion using another perspective, and the question does ask us to use at least two ways. So let's look at another way to do this. Let's look at the constant multiple perspective. So using the constant multiple perspective, we're saying 1 times what is 105? And the answer to that is it's 105. So thinking of it, that means that 105 should be the constant multiple for every relationship between input and output of the table. So if I take 1 times 105, I get 105, but then I should be multiplying everything else by 105, the 2, the 4, and the 10, and that should come out to be the 135, the 195, and the 375. Let's see if that actually happens. If I take 2 times 105, I get 210. If I take 4 times 105, I get 420. And if I take 10 times 105, I get 1050. In none of these cases do these numbers agree with what's in the table. Therefore, again, the relationship is not proportional. So what we have verified is that the relationship between the number of months you joined and the total cost in dollars is not proportional. So no, total cost is not proportional to the number of months you have been a member. Let's continue with this example and look at it a little further. Is the change in total costs that you've paid to the gym proportional to the change in the number of months that you have been a member? Justify your answer using at least two of the ways of thinking proportionally. So in here what we've done is we have created a column to track the changes for both the months that you changed and the number of months you've joined, and also the change in total cost. So thinking about this, recall that the ending value is some change in value plus the starting value you began with. And that could be written as V2 is equal to delta V plus V1. Thinking back to a previous example, we tracked the changing weight of an individual. And so when the person went from 231 to 216, that was a drop of 15 pounds, so we used negative. And if you look at it, negative 15 plus 231 is 216. But because addition is commutative, we could also say 231 plus negative 15 is 216. And then 216 plus negative 17 is 199. And 199 plus 6 is 205. So that is how that formula works. Now actually, let's look at what's happening here. So we're trying to figure out what are the changes. So to figure out the change from 1 to 2, you're saying 1 plus what is 2? Well, that number is 1. 2 plus what is 4? That number is 2. 4 plus what is 10? That number is 6. So it's pretty straightforward to see how we get the changes. Now, in this situation, a starting value from which all changes are determined is called a reference value. But in our situation, we did not have a specific reference that was used in this question. We kept changing our starting and ending value as we moved through the table. An example of a reference value would be something like, if I'm starting from 1 and I'm making all my changes relative to 1. That is not how changes are tracked in a table normally. But if we did use a reference value, it would be something like, if I start at 1, how much does it take to change to 2? That would be 1. To go from 1, the reference value, to 4, that would be 3. And going from the reference value of 1 to 10, that would be a change of 9. So that's how a reference value would work. We did not have that in this problem. There are other ways to find the changes between values. So for example, you could also say the change in value is the ending value minus the starting value. And the way that works is if we look at this table, we're saying this one could be figured out by taking the ending value 2 minus 1, which was the starting value. 2 minus 1 is 1. This ending value minus this starting value, 4 minus 2 is 2. And this ending value minus the starting value, 10 minus 4 is 6, which actually, in this case, would be much more efficient and simpler to do. So really you have options, and depending on the way your table is made, you might find using this version of the relationship more easy, or you might find this more easy to use and more efficient. So the way we're going to look at this is that delta n, the change in the number of months, is n2, that ending value, minus n1, which is that starting value. Now let's look at the other side of the table as well. We'll use this idea of the ending value minus the starting value to fill out this portion of the table. So delta c is equal to c2 minus c1, that second value minus that first value. So we're going to take 135 minus 105, that gives us 30. We'll take 195 minus 135, that gives us 60. We'll take 375 minus 195, and that gives us 180. So as we look at it, what we're interested in checking out is whether the change in total costs, which is represented by the values in this column, is proportional to the change in the number of months you've been a member, which are the values in this column. So first let's check out using the constant ratio. So if we take 30 divided by 1, that's 30. The ratio of 60 divided by 2, that's 30. And the ratio of 180 divided by 6 is also 30. So in this case, the ratio of the changes is proportional. Each of them were 30. Now let's look at it using the constant multiple. The idea of constant multiple is you're saying 1 times what is 30? Well, that number is 30. So that should be the constant multiple that relates the values of the input to the values of the output. So let's see, 2 times 30, that does produce 60. And following 30, further on, 6 times 30 is 180. So looking at this, we do have a proportional relationship. So it follows that the change in the total cost is proportional to the change in the number of months that you have joined. Now we have actually discovered something that has a specific name. It's called the constant rate of change. The two quantities are related by a constant rate of change if the changes in quantities are proportional. And it turns out that constant rate of change is that constant multiple, and it's also the same as that constant ratio. In this case, this constant rate of change in this problem is 30. So let's take a look at a summary of what we have learned in this particular example. So if two quantities are proportional to each other, then we have these three perspectives: the scaling, the constant multiple, and the constant ratio perspective. So the first question we had was, were the quantities proportional? So the quantities are described by what's highlighted in red right here: the number of months you joined and the total cost in dollars. So when we went through the analysis, no, the quantities were not proportional. We verified this using two different ways. Now let's see the other question. Were the quantities related by a constant rate of change? So again, let's think about what the word constant rate of change means. It says two quantities are related by a constant rate of change if the change in the quantities are proportional. So what we have to do is look at the change in quantities. It's highlighted by these red rectangles that you see here. And when we went through this analysis, we did find out the changes in the quantities were proportional. Again, we verified these two different ways. So the big takeaway is that when you're looking at these questions, oftentimes you'll be studying whether the quantities are proportional, or if the quantities are related by a constant rate of change, which means you're looking at whether the changes in the quantities are proportional. And that is one of the big ideas of this example and other similar examples that you'll be seeing in your homework. I hope you found this helpful.